Good morning, everyone. I'm Andrea Novaro. I'm a PhD student at the University of Torino at University IUSS Pavia. And today we talk you about the health effect of climate change. And in particular, we will focus on the extreme event and on the importance of looking at them from a long-term perspective. So, no? Okay. Before starting, just a quick note. Tomorrow during the session of Essay 2.4 at 11:45, I will give you more details about my study, the effect of cumulative exposure to extreme weather event on children's respiratory system. In the presentation, instead, I will give you the broader picture. Two more disclaimer. You will see two icons on my slide. The clock marks topics I will explain more in depth tomorrow. And the work in progress senior marks results that are still under investigation, so maybe the result may change in the next month. So let's start with the extreme events. If we use a very simple definition of heat, so maximum temperature above 30 degrees, and we look at the city of Turin, we can compare the exposure of 4 different people, each born in a different decade, so 1970, 1980, 1990, and 2000. And we can clearly show that the exposure are dramatically rising, and this is not, of course, is not surprising us. But this raises has a key question: how should we study their effect over time? The effect of extreme events can be studied in two ways. One is the long term, and the other one is the short term. So the short term study what's happened immediately after the events, or in the following day with a lagged. And we have a lot of evidence here. There are a lot of studies on heat and mortality, thunderstorm and asthma drug consumption, or heat wave and hospitalization, and so on. The long term, we have only a couple of studies, both published this year. This approach look at the lasting consequences of the events and the chronic effect that remain over time. So these two approaches, of course, rely on different hypotheses about how the risk evolves. So the short term suggests a peak in risk right after the events and followed by a return to baseline. The long-term approach is less interested in the peak. It suggests an upward shift in the baseline risk after each event. In this talk, we will focus on the chronic effect. And of course, for do that, we need the right tools. The tools is the longitudinal design. So the study that follow people, the same people over time, observing exposure, health outcomes, and usually also personal characteristics. And this allows us to understand how exposure shape the health later in life. One of the most common design is for sure the cohort studies. To give you an example, just a snippet of tomorrow's presentation, we studied the impact of exposure to extreme events in the first 6 years of life on the respiratory health at age 7. So the population come from the NIFEA birth cohort. We enrolled more than 7,000 children recruited between the 2005 and 2016 across the whole of Italy. And at age 7, we collect the health outcomes. This case is the wheezing, for more than 4,000 children. The prevalence of the disease is 5.6%. How we design the study? The study is designed using this 4 parts. So basically, we firstly generate the individual climatic series. So we use the geocoded residential address, and we follow the people along the life, and we use some climatic database. This case is ERA 5 land, to compute the individual climatic series. Then we try to summarize this climatic series using some climate indices. In this example, I will use just the heat defined as number of the day over or equal or above 35 degrees. And then we perform, of course, the statistical analysis to assess the health effect. Effect. So we can show, I put here the odds ratio for 10 additional days with maximum temperature equal or above 35 degrees, and the odds ratio is 1.12 for the 10-day increase, of course. The result is, of course, consistent with what is suggested by the short-term studies and also by biological mechanism. So health exposure may increase airway inflammation, oxidative stress, and modify immune response. So it's completely consistent with the other studies. Of course, looking at the people over the time, we can ask a deeper question. So we can ask, how do exposure across life shape health? And this is the idea of the life course hypothesis. So two are the main model that we can use in this context, the accumulation one and the critical or sensitive period. The accumulation one, so every exposure contribute equally to the overall risk. So more exposure someone experience, higher the risk, regardless on when they occur. The critical or sensitive period, instead, the exposure have different effect depending on when in life they occur. So, for example, the same exposure may be more harmful in the early childhood than in the later adolescence. These hypotheses are powerful because they help us to understand when and how intervention could be most effective, of course. So using these two hypotheses, we can do a step over. So these are the work in progress senior, so still under investigation. We can use the accumulation model. The example they did before was on the accumulation model. So we look all the exposure on the same, has the same effect over the time. But we can do a step forward, so we can analyze also the dose intensity response relationship. So we move from a single exposure, temperature equal or above 35 degrees, observing to observe the effect for a single dose, for a single intensity. Dose is the number of days, intensity is the temperature of each day, and response is, of course, the health outcome. If you look at the graph, you can see that for higher intensity and higher dose, of course, the risk will grow. Using the second life course hypothesis, we can instead looking at single odds ratio, so the overall odds ratio for the all 6 years of life. We can estimate age-specific odds ratios. Preliminary results suggest that the stronger effects are in the in the first years of life, and later the decrease. But of course, the exposure does not affect everyone in the same way. So we have to have a broader point of view. So social and contextual factor or environment can change how people cope with them or are exposed to them. So, for example, socioeconomic status, access to healthcare, gender, coping capacity, and so on. So the health effect of climate stress are not only biological, but also social determinate. And they're also shaped by inequality and social condition. And finally, exposure, of course, do not occur in isolation. We studied just the exposure before, but they are not isolated in the life of the people, but they are only on a part of the picture. People are exposed to many stressors at the same time. So to do some example, we have pollen, we have humidity, we have air pollution. Of course, maybe in a heat wave, the heat wave is painful because the direct effect, but also because we register high levels of ozone or PM, and that can amplify respiratory effect on children or on people. So to conclude, the health risk from extreme events can have a lasting effect beyond the event itself. Longitudinal study help us to understand this impact, and exploring how exposure affects health is key for model selection. But also personal contextual factor and co-stressor are very important in assessing health outcome. So finally, just a big thank to my co-authors, so Silvia, Maritano, Lorenzo, Richiardi, Giovenale, Moirano, all the Epidemiology Biostatistics unit of the University of Torino, and also to the Trump Foundation for the Travel Award to young scientists. And of course, to you to listen to me.